Again, if I wasn't versed in what Wells is doing, which is really a lot of pattern recognition, I probably would go right in for the rational root theorem, try to find one at work, do a long division. But really, to make that work, I need to find two rational roots to do a long division, get a quadratic, then factor the quadratic, use quadratic form in front of remaining roots. So what I'm going to claim over here is that I'm looking for a pattern. So to look for a pattern, what I want to point out, I want to look at the first two terms, and I'd factor x squared out from the first two terms. And what would that give you? That would give you x squared minus 2ax. And I want to complete the squaring that. And again, I'm just looking at the first two terms. Well, I take half of the coefficient. Let's see if I did that right. Half of the coefficient, which would be minus a, and square it, so plus a squared. Oops. Again, I'm just working with the first two terms. If I do that, though, I'm adding an x squared, a squared on it. I got to take that away. Again, this might say, you might say, that's crazy. You're making it worse than it was. I just did that. Now let's write the rest of it down. All right, I'm going to look at this thing first. And the whole point of this was to recognize a square. I see it. And what do I see? X squared. And then I see x minus a squared. All right, I'm going to do the next thing. And I want to point out what that is. I'm going to be looking at, let's see what I'm going to be looking at now. I'm going to be looking at these three terms over here. I want to do that on the side somewhere. And that would give me minus 18 x squared a squared plus 18 a cubed x. And what I'm going to do is I'm going to factor out minus 18 x a squared and then what would you get over there? You'd get x, let's see if I did that right, minus 18, yep. And then minus, looks like you get minus a, right? All right, I'll write that down now. Let's see, a squared. I'm going to write it as x minus a. All right. Last but not least, you have the 72 a4 equals 0. So I kind of landed here, and I'll point out where I am. I'm focusing on this now. Whoops. I'm focusing in on this. And it looks like I might be able to factor it. I'm going to start to erase all this prior work, by the way, because I'm done with it. I really need to look back at that. And I'm thinking maybe I can factor that. All right, so let's put that down. Looks like a tough factorization, but I think I can try. So I'm going to say x minus a, x minus a, this equals 0, of course. So I got this part done, and now I'm looking at this. And I'm thinking, you got to get an 18 in the middle, right? I got to think about that now. 72, 36, and 2. Well, I could do 4 and 9, right? I could do 2, 2, 3, 3, and a 2. Cross these out over here. Let's see, 9 times 8, yeah, 72. Kind of looking for combinations. I'm going to say 12 and a 6. 2 times 2 times 3 is 12. 3 times 2, yeah, let's give it a try. So I'm going to say 12a squared and 6a squared. That certainly gives me 72. And I need minus minus now. Now I realize what some people are going to say, oh, your work looks different than the work up there. You're right, sometimes it does look different. Sometimes one day I do it one way, another day I do it another way. And you need flexibility too, by the way. So I'm looking at this over here, and what I need to do is I realize that for this to be true, that these factors here, whoops, these factors here must be 0. Well, you know what, I got to write that down now. So I'm going to get my eraser out again. Eraser's business up here. I'm kind of done with this. I'm pretty convinced going forward is working out for me. And I want to do the next thing, which is getting those things to be equal to 0. So let's take the first factor, and I'm going to simplify it. And what do you get? You get x squared minus ax minus 12a squared is equal to 0. And that looks factorable too. Let's see. Looks like 3 and 4, right? Let's make sure that works. It gives you x squared, yeah, minus ax. Yep. And then minus, yeah, looks good. So what's x? It could be 4a, or it could be minus 3a. By the way, that's in the list of rational roots, by the way. If you want to check it, you can check it. I'm just going to check in the key when I'm done. So we just did this one. We're going to do this one now. What do you get? X squared. You know what? I should highlight these. These are answers now. You get x squared minus ax. And then what do you get? Minus 6a squared. Well, I'm going to try this. I'm going to say 3 and 2 minus plus. And what do you get there? X equals minus 2a, or x is equal to 3a. Okay, I'm going to commit to that answer now. I want to look in the key, though. Plus or minus 3a. Do I see that? I sure do. I see it here and here. 4a. See it right there. Minus 2a. Minus 2a. Again, if you want to check them, you can. Thank you.